Hi class, welcome to learning about hyperbolic conic sections. I don't know what it's called. Hi Mr. Alfredson, you're the class. Anyway, conic sections are when you have a plane and it intersects a cone, like these. There's four types. There's four types of conic sections. There's the parabola, which I think is when the plane is like parallel to like the slope of like the side of the cone, I assume, so it makes like the line is a parabola. It makes sense. Then you have a circle for when the plane is perpendicular to like the axis along the cones, and then you have an ellipse when it's not parallel and it's not horizontal and it's not vertical. And a hyperbola is when it's vertical. It's like that. So you have two lines. It makes sense if you think about it. It really does. I'm telling you, it makes sense. You just gotta pretend it makes sense. But it makes sense. You know? I know. Anyway, so if we go to Desmos very quickly, there's some real. Let's do some real interesting thingamajig. Let's do a circle first, right? Let's do a circle first. That's not the right key. That's a circle, if you can believe it. If you can believe it, that's a circle. So now, circles have that little thingy where you can go like minus h, minus k. If we add the sliders, now we can move the circle around. Isn't that just wacky and crazy? But what if we don't want just a circle? What if we want an ellipse? What if we want to be able to stretch this little circle out? What if we want to do that to the little guy? Well, then we need a squared and b squared to come into the equation. Literally the equation. Now we can bada bing, bada boom. We can stretch this guy out, or we can, or that way. Isn't that wacky and crazy? Isn't that just so cool? I think that's so cool and awesome and crazy and wacky and cool. Let's reset these back to 1. Now, why these are squared, I'll get to that. It makes sense. It does. But you'll have to wait. But it does make sense. I promise. It makes sense. So that's how like circles and ellipses work, right? And that makes sense. That makes sense. So that's these two. These are the simple ones. Now a parabola, I think we all know the parabolic equation. That's not too hard. I'm not going to explain that one. I don't really know how it relates to conic sections, but that's besides the point. But a hyperbola, that's what we're going to be learning about today, because it's cool and wacky. Now, how do we get a hyperbola from this general conic section thing? Well, we change it from a plus to a minus. And then bada bing, bada boom, what do you have? You have a hyperbola. Ain't that wacky and absolutely crazy? I know. I know. It's it's really something. It really is. And now these things, they still do the same thing. They kind of stretch it, maybe make it more narrow, make it like that. You get it. This one makes it like more narrow or not narrow. This one kind of moves it further in, and you get the point because you're smart. Isn't that right? Let's reset all this back to 0 so it's centered. And this is our pure hyperbola form. It's simply x squared minus y squared equals 1. It could give you this. Easy peasy lemons and squeezy, as the kids say. So that's cool. And now let's do our little example. Write your name. You got to remember to write your name. And if you write the date, if you don't write the date, I won't know when you did the paper, and I'll have to throw it out. Therefore, failing you for the year, since this is your only piece of work for the entire 2 semesters of this year. And then you'll have to retake calculus. Sorry, guys. Actually, you'll have to retake arithmetic and how to read. So let's do our little example problem. This is all just the stuff I just showed you, uh, which the foci and the the it makes sense. So guys, so gamers, as we say in the industry. This is our example problem. Now, my partner in crime, Josh Schragen, he's not a master of formatting, so I'll explain to you how all of this works, if I can figure it out. So, we have our hyperbolic equation here. Let's just for fun plug that into Desmos. That didn't work. I'll say it. That's not what it was supposed to do. Let's don't mind me fixing this. You know what? This is part of the lesson. Calculus is all trial and error. Isn't that right, Mr. Alfredson? So this is the hyperbola that we've just been given in this problem. It's centered on 0, as we can see, because it's just x squared and just y squared, so h and k both equal 0. And that's how we get the fact that the center is 0, because h and k just not there. Therefore, they're 0, therefore the center is 0. Because what the center always equals, the center is just hk. It's that easy. It's that easy. Center, easiest thing in the problem. Now we have the two things that I haven't explained yet. We have the vertices, we have the foci, as the kids say. Very cool and good of them to exist. Yes, I think so. So the vertices are these. These are the vertices. Actually, let me get back to this one. These are the two vertices. It's where the thing is furthest towards the center. And then the foci are somewhere in here. And let me explain to you how we get them. Now, I will say, my partner in crime, Mr. Schragen, did not exactly explain how you get them here, so I'll have to explain it myself. Now, he did explain this part, but not this part, because he's a little foolish. So, the vertices will always be on the same axis that, like, this is on. So here, this one's on the x-axis. If we switch this around and had the y here and the x here, it would actually be vertical. But that's irrelevant. We're just going to pay attention to the horizontal ones because we're lazy. So, all the vertices are obviously on the x-axis, and so are the foci. And I will point out, going back to these guys, these cool dudes, the foci on the hyperbola are always further from the center than the vertices, whereas on an ellipsis, the foci are closer to the center because they're inside the curve, and it makes sense. Don't think about it too much. It just makes sense. So now technically this is the wrong formula because technically the formula isn't Pythagorean's formula. If I remember it whatever it is, if I remember correctly, it's actually b squared equals c. Wait, no. Yes, b squared equals c squared minus a squared or something like that. And it's like kind of the same thing as Pythagorean's theorem. Not really, but also it is. It makes sense. It makes sense. You get it. You understand. You understand. It all makes sense. So, what we do for... I just realized I skipped this part. So that's fine. We're going to skip to the foci. Why not? We'll go back to the vertices. So this is how you find the foci. You need c squared. And then c is how far away the foci are. So c squared equals a squared plus b squared, because that's the same thing as whatever I just said. C squared equals 9 plus 4, because a squared is on the bottom of the fraction, b squared on the bottom of the fraction. Add them up. What do you get? 13. C squared equals 13. C equals plus or minus radical 13. And what do we see? Look at that. Foci plus or minus radical 13. Isn't that astounding? I know. I'm pretty cool. Then bada bing, and as the kids say, bada boom. Now we have to do vertices. So vertices are actually also quite easy. I believe you just look at a. You just look at a squared. That's it. It's just a squared. That's all. There's nothing to it. It's just a squared. So or rather not a squared. It's just a. Excuse me. So if a squared is 9, square root of 9 plus or minus 3. And what do you know? Vertices are 3. You know what? Let's put them on the Desmos graph. Let's say exactly. Now, I will say that's how you calculate the offsets, but you would also have to add h and k in here. because you'd have to add the center so it's not just like floating off to the side, but you get what I'm saying. You get what I'm saying. You have to. And if you don't, you're a sad little guy. So let's just do this. We're calculating like the offsets from the center right now. So the foci equals c squared. So c squared is a squared. Nope. Where's the key? Here it is. Plus b squared. But the square root of that. I forgot to put the square root. So if we plot those, I don't know why I did A. That should be B. But you ignore my stupidity, right? You're a benevolent man, Mr. Alfredson. So this is the foci and that stuff. So if we edit this, the foci moves, the vertex doesn't move. They both move. Now, you will see if we move this, doesn't change. Why is that? Because here we need to add in H, K, it's 0, so it's just K. And now if you can see it moves with it, and it still works swimmingly. And it just makes sense. Ooh, that's cool. No, it's not. Never mind. I lied. Anyway. So that's fantastic and great and good. Sure. We get it. We get it. We get it. That's how you get these things. Now, what's this? What are we looking at over here? I'm realizing this lesson is already 12 minutes long. I don't care. I'm doing the full thing. Mr. Alfredson, you can skim through. I'm not re-recording this. Your lessons are like 40 minutes long. I don't know what you expected. So, here, what we're getting is the asymptotes of the conic section. The asymptotes here are not like the x-axis. They're diagonal, because if you zoom out really far, you can tell that these basically get straight. It is Pride Month, but they are straight. So, how do we find what the diagonal asymptotes of these conic sections are? Well, my friend. Now, I may have forgotten to read up on this part just a little bit, but that's okay. We can learn together. So we're going to use the same y minus k equals plus or minus b over a, x minus h formula. Now, if you can believe it, we already have most of these variables. We do. And we just plug them in. Bada bing, you got a bada boom, and there you got your asymptote. So, asymptote, whatever. Let's do that. Let's if I can speak English correctly, do this. Now, what do you know? It's plugging it in for us, but it's not that hard. You literally just substitute it in. We've got that, but we've only got one of them. That's where that plus or minus comes in. You gotta do it again with the negative slope. No, you know what? Same color. And now you can see that they converge with those lines. And if we were to change these values, I'll say it, that doesn't look right. No, it doesn't. You wouldn't be wrong if you told me that doesn't look right, and I have a feeling it was B over A. You're right. You're right, Mr. Alfredson. I made a mistake. You're right. Thank you for correcting the teacher. I do appreciate it. Now, if we were to edit them, it would follow it. Zoom back out, it converges. No matter what values we put in, it always converges with the thing. Wow. Alright. Cool. So that's the example problem. Now do the practice problems. I don't know if I have to do these in the video, so I'm going to anyway. The practice problems, easy peasy, what the kids might call lemon squeezy. So. Right. First, let's identify our variables. What's a squared? A squared is 25. A equals 5. B squared equals 16. B equals 4. Square root them. Or, sorry, it's plus or minus. I'm just not writing that because plus or minus doesn't look very good on a normal keyword. Now, I could go into insert equation, but that's a lot of work, so I'm not going to. Sure, that's easy to identify. Now, what's h? Well, it's -1 because x plus 1 it's x minus h. So it's that. What's k? It's 2. So center equals hk, right? Therefore, the center is -1, 2. Easy. Lemon poggers, as the kids say again. Kids say a lot of things. So then what's v? Well, okay. I'm used to programming, can you tell? So, the vertices. What was the vertices? That's right. If we look up here, it was just plus or minus a. We already got a, which means the vertices are, if I can type, 5, 0, right? No, wrong. Incorrect. Fool. If you thought that was right, you were wrong. Because what are we forgetting? That's right. You need to add h and k, because otherwise it'll just be floating off to the side. Remember that? Yeah. So, we gotta add h to this side, which, let me tell you, that's -1, so we can just do that. And k to this side, there's 0, so it's just k. Now that's our vertices. And our foci. What are our foci, you may ask? Well, that's what we need to calculate. I don't know why I said it like that, as if you didn't know how to calculate it. So, we're going to need this again. What is our foci? Remember how we do it earlier? C squared equals a squared plus b squared. What's c squared? Well, c squared is 25 plus 16. What's 25 plus 16? That's right, it's 41. Is it 41? It's 41. Yep. I can do math in my head. Excuse me. So, it's c that we're looking for, so it's actually the square root of 41. Now, don't forget to add k. Nope, outside that. Don't forget to add, sorry, h. So, plus, nope, -1, and k. And bada bing, bada boom, you're right there. Just kidding. You need to find the asymptote. I don't remember typing that. That's probably because Josh typed it. I'm a fool. A buffoon. So, y minus... I know how to speak. Y minus k equals b over a x minus k, h. Wrong one. Easy. Easy lemon, easy lemons. Easy lemons, as the adults say this time. I'll spice it up. So, add, substituting k, we got 2. B over a, what's b over a? B is 4, a is 5. So, let me add a fraction. We actually do need a plus or minus here, because it's plus or, it's, yeah, sorry. It's a plus or minus here, I just didn't write it. And then substitute an h. Bada bing. A bada boom. And what do you have? You have the asymptotes. Easy. Easy peasy lemon squeezy. Mr. Alfredson, I'm at 20 minutes. I don't know how you expected us to fit this into 10 minutes, because I'm also, like, yeah. Sorry. Alright. And I'm not re-recording it. I do have to get ready for prom. So, oops. Oopsies. Silly me. 2. Time to do the exact same thing over again. A squared. What does it equal? That's right, it's 4, which means A equals 2. B squared. What does it equal? That's right, it equals 9. And what does that mean? It means B equals 3. The bandage on my leg just came off, one moment. Anyway, so, H. What does H equal? If you guessed that H equals 2, well, that is a good guess, but you shouldn't have guessed. It's very easy because it's minus 2, and since it's minus H, it's positive 2. So, you shouldn't have guessed on that, you silly, silly. K. What is K? That's right, King K rule. That's what K is. But K is also negative 3, because it's plus 3, so it's negative 3. It makes sense if you think about it. What's the center? That's right, it's HK, so the center is 2, negative 3. Now, what's the vertice? What is the vertices? That's right, it's plus or minus A, so 2, plus H, so 2, and then comma K. No, K. And what is the foci? That's right, the foci. I keep saying that's right as if you say something and I can hear you, but I can't hear you. I'm imagining you talking, Mr. Alfredson. You're like a little voice sitting in my head, telling me the answers, except I know the answers. And you probably also know the answers, seeing that you are a calculus teacher. Maybe. So, the foci, what was foci? That's right, c squared plus equals b squared plus a squared. Why I say it like that, I don't know. So, foci is plus or minus c. What's a squared plus b squared? Well, it's 4 plus 9. What's 4 plus 9? That's 13. What's the square root of 13? It's the square root of 13. So, it's the square root of 13 plus h, comma, k. And now we just need the asymptotes. Easy peasy lemon squeezy. So, y minus k. I'll write this as an equation this time. Y minus k equals b over a x minus h. And I'll have you believe it that yes, you can just substitute things. Y plus 3 equals plus or minus. I need a fraction. B is 3. 2 is a, or a is 2 rather. X minus 2. And that's our asymptotes. We could use the graph to check ourselves, but I'm lazy, and it's 1:40, and I have to start getting ready soon. So, that's your that's your lesson. Do the exit tickets. I feel like I'm pretty sure I don't have to do the exit tickets on the video because you're supposed to be exiting the class, and I can't hold you after the bell. That would be silly of me. This one, extremely difficult. It might take you years to figure it out, but you can do it. This one, same difficulty. There's an answer key down here. It's pretty good and cool. Ignore this until after you've exited the room and you've handed the paper back to me. Then you can look at these. Alright. Haven't oh, the bell's about to ring.